Welcome! Today, we're excited to talk about the new version 1.2 of CET.SteelConnDesign. This software is perfect for modern steel connection design, and the best part is it's free. In this update, we're focusing on designing column transverse stiffeners for beam to column flange moment connections using FreeCAD. Let's dive in and discover the amazing features of CET.SteelConnDesign 1.2. Before we begin, it's important to note that this version exclusively supports full-length transverse stiffeners. Additionally, we assume that users have already installed the latest version 1.2. For instructions on how to download, install, and set up our system with FreeCAD, please visit our channel. Now, let's start by running FreeCAD. Next, we need to select the CET.SteelConnDesign workbench to launch our system. Once our system is loaded, users will immediately notice that the version number has been upgraded to 1.2. To begin the connection design process, let's create a column named C1 and a beam named V1. Once these members are displayed in the list, we can proceed to create a connection between B1 and C1, known as B1_C1. Now, navigate to the Connection Design tab and input a moment load of 2200 kip-inch. By clicking the Design Connection button, we'll observe the creation of beam to column flange moment plate connections. Additionally, column transverse stiffeners will be generated for us to review. In the Connection Design tab, we can choose to change the beam size to W18 by 50 and the column size to W14 by 74. Once the design is complete, the sizes of the members will be adjusted accordingly. Furthermore, in the Design Parts drop-down list, you'll notice the addition of the Column Transverse Stiffener option. The Design Parts drop-down list plays a crucial role in CET.SteelConnDesign as it enables easy navigation between members and different connections. Let's select Column Transverse Stiffener as the design part. This will display a new image depicting the column stiffener, providing a visual representation of the input fields and their meanings. Please note that our system currently supports only full-length stiffeners, which means the length input field cannot be altered at this time. If the user decides to modify the width to 3.5 inches, the stiffener in the 3D model will reflect this change after the design process. However, if the user chooses to undo the last operation, the stiffener will revert back to its previous dimensions. Next, let's navigate to the beam and modify the moment to 1500 kip-inch. After design, we will observe that our system will design the moment flange plate connection without column transverse stiffeners. This is because stiffeners are not necessary for the given moment load. It's important to highlight that our system only designs stiffeners when they are necessary, as the detailing process can be costly. We recommend users to choose a larger column size to avoid the need for transverse stiffeners altogether. In certain situations, if a user enters dimensions, such as 0.75 inch for the clip length, our system will automatically design the stiffeners accordingly. Additionally, the summary table has been updated to include the capacities for column flange local buckling, column web local buckling, and column web crippling. If the column size is modified, these capacities will be adjusted accordingly. Now, let's open the detailed report. Here, you can review the calculation details for column flange local buckling, column web local buckling, and column web crippling. These equations are displayed in an easy-to-read format, powered by LaTeX. Furthermore, the report also includes the requirements for the width and thickness of the transverse stiffener as specified by the AISC manual. These requirements are clearly printed for reference. The last section of the report covers the calculations for the weld between the stiffener and the column web and flange. In the final part of this presentation, we will discuss the 2D drawings for the stiffeners. Before we proceed, let's adjust the drawing settings. To do this, go to the menu, select Preferences, then navigate to Tech Draw and Dimensions. Uncheck the option for Use Global Decimal and change the dimension format to %.4W. After configuring the Tech Draw settings, we'll switch the view to the top view. Then, we'll navigate to the Tech Draw workbench. Firstly, we'll create a default drawing, and subsequently, we'll add the top view of the stiffener plate to the drawing. Then we switch the view to the front view and add the front view of the stiffener plate to the drawing. We can include the dimensions of the clip length and plate thickness in the drawing. That concludes today's presentation. If you have any questions, please feel free to contact us at civiliengrtools@gmail.com. Thank you for watching.